Hi, my name is Natalie Ursid, and today I'll be sharing with you my second physics lab report for the UMass Amherst Winter Session 2023, titled, Is the acceleration of the iLab device the same moving up versus down a ramp? We were given the claim, the acceleration of the iLab device is the same rolling up versus down a ramp, and asked to determine whether or not that claim was accurate. We used the wheel sensor on the iLab device to measure the acceleration, position, and velocity of the device going up versus down a ramp. We believe that the claim was false and created some hypotheses shown here in the pink box. For experimental design, we took a baking sheet and placed it at roughly a 15-degree angle. We did not use a backstop for this experiment. Rather, we used the position returning to 0 to be indicative of whether or not the trial was complete. For the purposes of this experiment, we defined the y-axis as the surface of the ramp which the iLab rolled on vertically as depicted on the iLab device. And to start, we placed the iLab face down on the y-axis at the bottom of the ramp. We push it up the ramp at a roughly the same level for each of the trials, and once it reached the top, we allowed the device to fall back down on its own. The 3 trials were conducted, and the data was averaged to ensure accurate measurements. We did assume that gravity was constant, friction is a force acting against the motion of the device, that the sensors were accurately calibrated, and then that the ramp was uniform, still, and rigid during all the trials. And then up here on the right, we have our data for all 3 of our trials. Essentially, we broke it into 2 parts of when the cart was going up versus down. So this first part represents the position here where the cart was going up until its maximum right here position when it reached the top of the ramp. At this instant, the velocity was actually momentarily 0, which you can see across all 3 of the trials. So we used that to determine when this instance was for our acceleration graphs. And then the second part is when the actual iLab was rolling back down, and we determined the actual end, which is represented by these orange dash lines, as this place where the position was exactly the same as it was when the iLab started. So the iLab had rolled up and rolled back down back to the initial starting location. So for the cart going up, we got an average acceleration of negative 1.007 meters per second squared with a standard deviation of 0.337 meters per second squared. And for the cart going down, we got negative 0.237 meters per second squared as the average acceleration with a standard deviation of 0.157 meters per second squared. So the average acceleration for the cart going up the ramp was less than that of the cart going down the ramp, which supports our second hypothesis. So this means that while the cart was moving up the ramp, its speed was changing faster than when it rolled back down because acceleration is the change in velocity over time. The standard deviations for both the cart going up versus down were very small, indicating that there is a clear difference and that these measurements are accurate. And we wanted to get into why this is happening. So we drew some free body diagrams shown here with their abbreviations for the forces down here. We drew all of the forces as vectors here. And then we use Newton's second law, the sum of the forces equals mass times acceleration, to mathematically represent the forces in what we determined was the y direction here. And you can see that friction when the cart is moving up is acting in the negative y direction shown here. And then friction is actually acting in the positive direction when the cart is moving downwards. So if you look at these 2 expressions, you can see that the top expression here, friction is negative. And we did take into account the y component of gravity as being negative here as well. So you can see that this value will always be smaller than this value in this specific instance. So that explains what's actually going on. Therefore, the claim is that acceleration is the same while rolling up versus down is false. Somebody could have come to a different conclusion by not including a force on the free body diagram or by incorrectly orienting a vector corresponding with a force, or not correctly identifying the parameters of like where the x and y axes were. We could have had some potential experimental errors. The baking sheet we used was a little dinged up, so that could have potentially caused some error. Or pushing the cart in a perfectly straight line up the ramp was a bit difficult, but we did the best we could. The calibration error could have been there, could have been small. The sensor was calibrated, but there still could have been a little bit of error there. The floor that the baking sheet was placed on may not have been truly horizontal. We didn't get up like a level or anything for that. And then we brainstormed some next steps for if we would want to make this experiment a little bit better for next time. So, like I said before, the standard deviations of both data sets were small, indicating that they were fairly accurate. But we could conduct more trials. So we conducted 3, but we could conduct more than that to increase accuracy, have a more rigid uniform ramp, or have a longer and shallower ramp to increase trial time, increase the data reliability.